All right, so this is the question for 2022 GCE. So this question on half-life, let's check how it was. So one thing that you need to understand about half-life is the time taken for a radioactive nuclei or substance to decay by half of its original. Half-life is the time taken for a radioactive nuclei or substance to decay by half of its original. So how to find the half-life is that the substance, when it has decayed by half of its original, you do like this. So the first question was, what was the original mass of the sample? So the original mass of the sample before it was touched, it is this one that is on top. So always where this line is curving on, the line, that's where the original mass was. So the original mass was 200 grams like this, or kgs, kgs. So the original mass was 200 kg, this one. Okay, so because this was the original mass, and we said half-life is the time taken for a radioactive nuclear or substance to decay by half of its original. So if the original is 200, so meaning to find the half-life of this, we say that half-life, it is the time taken. So half-life is time. It is not mass. Half-life is time. So it must come on time here. So how are you going to find it? You say the original mass here was 200. So you say 200 divided by 2, because when it decays by half of its original. So when 200 decays by half, it will give you 100. It will give you 100. So this 100 is not the half-life. This 100, it will help you to locate the half-life. Half-life is time, so half-life must be found this side, not this side. So when the 200 has decayed by half, it will give you 100. So you go on the graph. You go on the graph now. When 200 has decayed by half, it will give you 100. So you go on 100 now. Then you draw a line like this on 100, on 100. Like this. Then where they meet, where they touch the curve, where it touches the curve, the line here, where it touches the line, then you must come down like this, okay? So when it go on 100, when it touches the curve, then you curve it, you come down. So meaning the half-life where it is here. So where it is, if this is 8, then this is 12, meaning here it is 10. So meaning the half-life was 10. So meaning the half-life was 10 days. You see? Meaning the half-life was 10 days. So what do you do again? We said that you get the original mass, which is 200. When it decays by half, it will give you 100. So that 100, it is not the half-life. It will help you to locate the half-life. You go on the graph where there is 100, the half of 200. Then you curve it like this. Where it touches the curve, then you curve it down. Where it touches the line, then you bring it down like this, then it comes down, meaning where it has come here, that's where the half-life is. So the first answer was 200. Here it is 10 days. Okay. Then what quantity of the sample had remained after 24 days? So to find the quantity of the sample that remained after 24 days, so what you do, you don't need to do anything. You just go, the quantity is this side. This side is the mass. The quantity is this side. So after 24, what quantity was left? What mass was left? Or what quantity of the sample had remained after 24 days? So after 24 days, what was the quantity of the mass that was left? So the quantity is this side. This side is the mass. So after 24 days, what happened? So you go on 24 here. When it touches exactly the curve, when it meets the curve, so you start on 24. 24 is here. So where they meet the curve like this, then you bring it this side. Okay. Yes, so you go where 24 is. So when it touches the curve, then you bring it like this here. So you check now. So if this is 0, this is 25, probably it was on 20 here. Okay, so it was on 20 maybe here. This is how you find the mass that was left. So maybe if here the answer was 200, this was 10, maybe here it was 20, the mass that was left after 24 days. So after 24 days, the mass that was left was 20. So this is what you do in case they ask you, if they say what mass was left after 8 days. So you go on 8, then you bring it like this up. Where it touches the curve, then you bring it down like this. Okay, so meaning this side, that's where the mass was left. Okay, yes. So let's proceed with the question. B is saying, if the sample decayed by emitting gamma rays and an alpha particle to produce a new element X, write an equation for the decay. So write an equation for the decay. So how do they decay? How is the equation? We said for an alpha particle, when it is undergoing a decay, we said that the formula is this. Here there is A, here there is Z. So when it has undergone an alpha emission, the mass number reduces by 4, the proton number reduces by 2, then to form a new element, then plus helium in nature, because it is an alpha radiation. Then if it is gamma, it remains the same. So gamma does not change. If it is gamma, it remains the same. The A will remain A, the Z will remain Z. It remains the same. So let us check how we can answer this one. So what was the question requiring us to answer? Okay, so the question is saying, write a sample if it has decayed by gamma and alpha. So here is the sample on top. 131 up, 53 down, iodine. So 131 and 53, so this was iodine. So when it has undergone gamma emission, this remains the same. It will be 131 here, and here it will be 53. It will be iodine plus Y, meaning plus gamma, the symbol for gamma. So this is for gamma. Gamma, it remains the same. Then when you talk about alpha now, alpha, the mass number reduces by 4. Then the proton number, it reduces by 2 because it is helium in nature. So if this is 53, it will be alpha. So 131 minus 53. So you get your answer there, 127. When you subtract 131 minus 4, you get 127. You reduce it by 4. Then the number that is down here, it is supposed to be reduced by 2. So 53 minus 2, you get what? 51. Then, so you go on the periodic table. Which element has got the mass number of 51, the proton number of 51? Which element has got the proton number of 51? Okay, so on the periodic table, it's antimony, which is Sb. Then you write plus helium in nature. So this is the equation for alpha. Okay, so give two properties of each of the following. Gamma rays. Gamma rays, what is the property? You say this one, it travels at the speed of 3 times 10 to the power 8. That's the property. The other property that you can give, you can say this is the electromagnetic wave in nature. It has got the highest penetration power. Okay. Or you can say gamma rays, they have the highest penetration power. The highest penetration power and highest ionization power. Then an alpha particle, you can say one of the properties, it is helium in nature. It has a positive charge. It is positively charged. You can also say an alpha particle has a weak penetration power and highest ionization effect. Mention one use of gamma rays. So a gamma rays, it is used in the treatment of cancer. You can use it in the treatment of cancer. So this was the question for 2022. Hope you've gotten something. This is Mr. Ruben Jovo. See you.